Electricians and electrical workers and anybody working around electricity, this would include somebody working with HVAC systems, your electronics people, even your IT guys to some degree get involved in working around electricity. Deal with hazards that are, well, to put it simply, they have severe consequences if they make a mistake. This isn't if I miss the nail, I bust my thumb. This is you may not go home at the end of the day if you make a mistake. Electricity is very dangerous. My father was a production manager and an executive with Dow Chemical, and he used to claim that electricity in his book was a necessary evil of production. I think anybody that's in manufacturing would probably agree with that. So the fact is that we have to work around it, and we work around it every day. I got my first exposure to electricity when I was about 7 years old and stuck a butter knife in an outlet. Of course, I'm the only one in the room that's ever done that, right? So, the lesson here is that we all are exposed to it. Our children are exposed to it. How do we protect our kids from sticking the butter knife in the outlet besides teaching them not to stick the butter knife in the outlet? We have little plastic things we put in there now to keep little children from sticking things in it. The point I want you to understand as I go into this is that the way we did things 50 years ago is not the same as the way we did things 100 years ago. The way we do things 20 years ago is not the way we did things 50 years ago. And the way we do things today is not the way we did things 20 years ago. What we have done over time is we have learned how to do things better, smarter, more efficiently, and protect the most important asset that we all have. And that asset's sitting in this room. Each of you is the most important asset your company has. Our employees that work for us, your contractors, are the most important asset that we have. So we have to protect that asset. So I'm going to talk to you a little bit about electrical safety because in the last 10 to 15 years, there have been tremendous changes in electrical safety and in the regulation associated with electrical safety. We've come up with some innovative things that help us with our maintenance, that help us with our electrical safety. 20 years ago, you didn't see infrared technology being used. And all of you probably know when I say infrared technology, how we're using infrared in our maintenance programs. It's something that's new that we've been using in the last 20 years. So there's a lot of this stuff that we utilize that keeps us safe, keeps our employees safe, and keeps your subcontractors and your contractors safe. I'm going to talk to y'all a little bit from a standpoint of the fact that y'all oversee contractors. And you deal with owners and ownership of equipment. So what I want to talk about a little bit first is what the standards are so you understand what this is all based on and what the foundation is. This document is NFPA 70E 2018. If you ever heard of it or seen it, raise your hand. That is not many hands. So this document provides practical safe working area for employees relative to the hazards arising from the use of electricity. If any of you, your jobs involve electricity in any way, shape, or form, raise your hand. That's the whole room. So everybody in the room has some involvement with working around or have people that work for them working around electricity. This document right here in 2018 requires training every 3 years at a 3-year interval. Requires by who? Well, we're going to talk about that. NFPA 70, National Electrical Code. Who's ever heard of the National Electrical Code? Nearly everybody's heard of the National Electrical Code. It covers the installation and removal of electrical conductors, equipment, raceways, signaling, communication conductors, equipment, raceways, optical fibers, et cetera, anything that might carry electricity or remotely related to electricity is covered by the National Electrical Code. These two documents make up the bulk and the foundation of how we keep people safe from electricity. Both of them are published by the National Fire Protection Association. And it's the reason why we have less fires and less houses burned down, less people dying in fires than we used to have, is because of the work that was done. And a lot of us say that these books were written in the blood of a lot of people. So NFPA 70E is requirements for safe work practices to protect personnel by reducing exposure to major electrical hazards. Originally, it was developed at the request of OSHA. 70E was not something some construction company thought of. It was developed at the request of OSHA by a whole lot of people in a consensus environment. NFPA 70E helps companies and employees avoid workplace injuries and fatalities due to shock, electrocution, arc flash, and arc blast. It assists in complying with OSHA 1910 Subpart S and OSHA 1926 Subpart K. These are OSHA regulations that require owners, workers, contractors, and anybody working around electricity to work safely around electricity, in a nutshell. It's important to note that following the procedures outlined in NFPA 70E will put you in compliance with OSHA 1910. Subpart I focuses on protective equipment. Subpart R is on high voltage maintenance and operation. Now, all this is a bunch of mumbo jumbo, so let me break this down for you real simple. What happens is, in Federal Register, volume 79, and I'm giving the specific references so you can look it up for yourself, don't take my word for it. Number 70, Friday, April 11th, 2014, Rules and Regulations. 29 CFR Parts 1910 and 1926, docket number, OSHA, this number here, covers electrical power generation, transmission, and distribution, electrical protective equipment, and revises construction and general industry standards. The last time that OSHA issued a final rule like this was in 1972. In 2014, they issued this rule, and they adopted NFPA 70E and the NEC as basically their foundation for the regulatory. There are 429 pages in this document. NFPA 70E is referenced 135 times in this OSHA document. So OSHA has basically incorporated 70E for all practical purposes into the requirements. I would guess the venture that only a handful of you, if that many, even knew this existed right now. So this here, I don't want you to read all this. I put this slide in here because some of you have heard the concept of continuous industrial process. It's in the National Electrical Code. It has to do with not interrupting the flow of work, to simplify it. So before we get into how this impacts you, I want to talk a little bit about the sources of electrical hazards. There are basically three sources. It is shock, arc flash, and arc blast. Shock is, of course, having current flow through your body, causes things like heart defibrillation, can stop your heart, can cause death. Most of the deaths caused in America due to electricity are from shock. Most of the debilitating injuries that cost tons of money in hospitals and painful recoveries are from arc flashes. Most electricians and electrical workers that work on low voltage systems, the arc flash typically is their fingertips because it's moving wires, it'll flash, it'll burn their fingertips. Electrical workers that work on medium voltage, 480 volt equipment, his entire bodies, even to the point of death. There was a utility here, it was this year actually, utility here this year, young man in his mid to late 30s. We had a couple of our guys working for a client at the job, the utility needed to de-energize and re-energize a transformer. They came out. Y'all probably have this happen in your buildings all the time. Utility comes, shuts this thing down, turns it back on. This young man was just doing that like always happens. He went back, came back to the job site to turn the switch back on, and he was ending up checking some circuits. Long story short, without details, an arc flash occurred, burned him badly. Put him on the ground. One of our technicians went over to assist him. All he asked was that we get the phone, get his phone, dial his wife so he could talk to his wife, 2 small children, talk to his wife while one of my techs held the phone. He went to the hospital. Several days later, he died from complications from pneumonia from his burns. This happened just this past year, right here in the Dallas-Fort Worth area. This happens all the time. So these are the hazards we deal with. A flash is simply a bright light. It's a flash similar to an arc welder. A blast is what happens when you have a big flash. It involves a concussion similar to what a grenade will do, or a small explosion. And I'm not going to bore you a lot with the definitions. A shock hazard is a source of shock. This electrical outlet, if I pull the cover off of it or I stick the butter knife in it, is going to be a source of electrical shock. Most people that are killed by electricity are killed by 120 volts and less. It does not take high voltage. That's why things like HVAC are in such harm's way also when they're working on HVAC systems. Arc flash hazard, source of possible injury or damage to health associated with possible release of energy caused by an electric arc. Now, just real quick and dirty, arc flash, the intensity of it and how dangerous it is based on the available energy or fault current, how long the arc lasts, and how far away from the arc you are. So the further you get away from the arc, the better. The shorter the duration of the arc, the better. And the less energy available, sometimes the better. Okay? So we have these hazards from electricity. So we got to control these hazards. OSHA says you have to control these. So the way we do this is through a series of what's called risk controls. These risk controls are in the order that they're supposed to be implemented according to OSHA. Now, so at this point, I want to stop and explain a couple things about how OSHA's handled this. Over the last 15 years, NFPA 70E has evolved, and OSHA has evolved with their involvement with it. What's happened is that it was decided 15 to 20 years ago they were tired of killing people with electricity and burning them up. So we decided in the industry this was going to cease and desist. So a lot of us working in the industry, a lot of people involved, worked with NFPA, we worked with OSHA, we worked with IEEE, and we started developing programs and systems to keep people from getting hurt and killed by electricity. Now, if I was to snap my finger today and say you cannot use gasoline anymore, what would happen to our economy? It would go in the tank. But we are working toward getting off of fossil fuel. That's something we are working toward in the future at some point. You can't just do it overnight. So OSHA realized that to snap their finger and say, you shall not anymore, would not work within the industry. So what they've done over the last 15 years or so is gradually started implementing things, changing things. And in 2018, we are coming to the culmination of the final product that OSHA was shooting for, and that is based on this one right here, and that's elimination of hazard. And what that means is zero working on energized equipment. Which if you think about it and you know anything about the work you have to have done, that's a big reach right there. Now, there are certain things that equipment must be energized to do. You got to have it energized and you have to have load on it to do a proper thermographic survey of it. So that's something that has to be. There are these rare exceptions, some troubleshooting that a control technician or HVAC technician has to do may require it to be energized. But what they've come down to and where we've gotten to today is that the first question that has to be asked is, can it be de-energized? Will it be de-energized? First goal is to eliminate the hazard. We eliminate arc flash and shock hazards by shutting the equipment off before we work on it. If we can't eliminate it, then it falls to substitution. An example of that is we use some remote racking systems to rack breakers in. Engineering controls, infrared windows that we put on equipment. We can put a window on the electrical equipment so the guy operating the infrared camera, can look through the window do the infrared survey and never has to take the cover off of it or be exposed to electricity. That's an engineering control. Awareness. We're doing awareness right now. This is part of the awareness aspect of mitigation or controls. Administrative controls. That would be a rule that you put in place. Any type of rule that would keep somebody from doing something. And then finally, personal protective equipment. What a lot of people don't realize is that personal protective equipment is the very last line of defense we want to put in place. It's not something you put on as part of being able to work on the electricity. It's something you put on so if you make a mistake, you'd still walk away. So these are the controls, and the most important one is the number one, elimination part of this. So they added some definitions in support of all of their goals to eliminate the people being hurt by electricity. One of those is an electrical safety program. A documented system consisting of electrical safety principles, policies, procedures, and processes that directs activities appropriate for the risk associated with electrical hazards. OSHA requires, thou shalt, by OSHA, every company has to have an electrical safety program. I'm going to say it again. Every company has to have an electrical safety program. Every contractor that comes to work for you, if the HVAC guy shows up, the contractor HVAC shows up, he's working for you, he's supposed to have an electrical safety program. Peloton's supposed to have an electrical safety program. Your owners that y'all are overseeing their stuff are supposed to have an electrical safety program. This is a requirement by OSHA. And this became a requirement, by the way, hard and fast in 2018. Just became a requirement. Hard and fast. Maintenance condition. Now, we all have different maintenance philosophies. Companies have different maintenance philosophies. Some of your owners may have different maintenance philosophies. One of the maintenance philosophies that used to exist was what was called run to failure. That means I've got a replacement sitting right here in my garage, so I run it till it fails. When it fails, I take it out and slap in a new motor, and away I go. You know? And I used to run my AC system that way until I moved to Austin years back, and then I quit running my AC system that way because I got stuck one time during a hot summer without an air conditioner. But anyway, I'll give you another one. NFL got to see how that worked one time when they had a blackout at one of the stadiums. They didn't like run failure at that point anymore ever again. We just happened to do some of the work for some of those stadiums. So anyway, that used to be a policy. It used to be a maintenance process. What they've said in 70E and what they've done by changing this is they say maintenance condition is the state of electrical equipment considering the manufacturer's instructions, the manufacturer's recommendations, and applicable industry code standards and recommended practices. That is what condition of maintenance is. Now, why is that important? That's important because what's happened now is the condition of maintenance of your electrical equipment is now come in as a factor and is considered as part of determining if the equipment's safe or not. In other words, it's just not a matter of reliability anymore. It's a matter of me walking up to the equipment and going, that equipment is safe or unsafe based on maintenance of condition, and if it's unsafe, then that changes what we can and cannot do with that equipment. So this now affects this. And let me explain something to you about this whole thing with manufacturer's instructions. I'm not going to tell you which major city it was, but it was one of the big cities in Texas. I ended up getting subpoenaed to testify in court between a manufacturing company and a school district because I did the investigation on a breaker that blew up and caught the school on fire. What it turned out was that the electrician, long story short, had operated the breaker about 6 times, and on the 6th time he tried to close it. It was a 4,000 amp circuit breaker, 480 volt. It blew up and it caught the school on fire. And they were suing, the school was suing the manufacturer for faulty equipment. But in the manufacturer's instructions, it's clearly stated, if the breaker trips on a overcurrent condition or a fault condition, you must determine the reason for the fault before operating the breaker and go through and inspect the breaker. That's in the manufacturer's instructions. So therefore, The school district dropped their subpoena, and the manufacturer subpoenaed me. So that's where we ended up with all of this. So this happens all the time, is what I'm telling you. These things come up. So exposed. It's important to understand exposed because it's as important that we work around electricity, know when we can, as to know when we can't. Otherwise, we're all frozen with fear and we can't work on anything. And we got to be able to work on things. So understanding that the shock hazard only exists when the conductors are exposed is important. This outlet right here has a cover on it. There's no shock hazard with this outlet because it's not exposed. If I pull this cover off and there's bare wires behind that cover, then it's exposed. We'll just leave it at that for now. So, some significant additions to NFPA 70E, which is indirectly what OSHA uses for their enforcement side. Employers' responsibilities, you must have an electrical safety program. Lockout, tagout was aligned with OSHA. And there's a new table that helps people determine when there is an increased chance of an arc flash. It gives you a matrix that tells you if you're doing this, then there's an increased chance. If you're doing this, but this, then there's not an increased chance. And then finally, and one of the last topics I'm going to talk about is human performance. Now, inspection. The electrical safety program shall include elements to verify new installations are inspected. You have to inspect new electrical installations. And it's got to be inspected by somebody that's qualified to do so. They added some service equipment. This is just labeling. You have to put labels on all your service entrances now. Marking, this is again reconditioned equipment. The electrical code allows you to use reconditioned equipment now. Again, pre-energization operating test. You have to inspect it before you energize new equipment. You got to document the test results on it, and those have to be made available to the authority having jurisdiction. There has to be a test report issued with it. Existing NEC requirements here, doing load calculations. If in your building you're going to add a load, by the code, you have to either do a calculation, an engineering calculation to make sure that you can adequately and safely add the load, or you have to do a load study on the facility to make sure you can add the load. That's all that says. Ground fault protection just simply states that your ground fault protection has to be tested. There's certain size limitations. I won't get into all the weeds with you, but know that if you have ground fault protection at a certain point, it has to be checked and tested. Now, the important part of this. You're going to have contractors working for you. And it don't matter if it's Wes's group or some other group or construction or testing or electrical or HVAC. You need to make sure that you're aware of what the requirements are so you can ask these contractors to make sure they are complying with those requirements. They must comply with them. Now, that's going to involve things like energized work. Can we not do energized work? And it's getting folks, right, quite honestly, where energized work is just not something. In the next few years, it's going to go out the window to where doing energized work for the purpose, because you don't want to turn the lights off because it may interrupt somebody's day, is not going to fly anymore with anybody. OSHA has clearly, in several cases, already clearly stated the fact that the interruption of production or inconvenience is not justification for doing energized work. That's crystal clear in their documentation. That's not a reason. It has to be a greater risk, and greater risk they narrowly define, or it has to be infeasibility. That's where your IR comes in. And then they expect you, if you're doing infrared on your buildings, if you can put windows and windows will work, to have windows. Now, windows don't work on a lot of things we do, so we still got to pull covers off. But here's the part about this when they added the human performance. Does anybody know where the concept of human performance came from? Anybody? How many people here ever worked in anything dealing with nuclear power? Anybody? Okay. So I come from a background, actually so does Wes, we both worked in the nuclear power industry. I spent 13 years in Navy submarines, so well, more or less in Navy submarines. So we came from a nuclear age, both in weapons and in nuclear reactors. So if the guy blasting using the dynamite, blowing the hole in the mountain to run a road through, made a mistake with the dynamite, he blew his hand or his arm off and maybe blew his buddy up. If I'm sitting in Norfolk, Virginia, moving an ICBM and I make a mistake with it, the wrong kind of mistake, then I end up wiping out part of the East Coast. So what they decided was that when it comes to nuclear power, we can't afford human mistakes. So they started really looking at human error closely. We also did it worked its way into NASA and the Space Agency, and in flight, we also deal with it with aircraft. That human performance, human error can be identified, and human error can be mitigated. So they've incorporated human error both more into OSHA's world and into the electrical safety world than they used to have. And what it says is, see, and you may have heard this yourself, somebody's been working electricity, you got the master electrician. Anybody master electricians in here? Any masters? Journeyman? Journeyman? How long have you been a journeyman electrician?
Probably 15 years.
15 years? Okay. I cannot tell you how many times what I've heard is, well, I've been working on electricity for 30 years. Experience, we have got this misconception that just because somebody has done something for 30 years, that they are more apt to do it safely. But I'll tell you something. If I'm having a bad day, I had a teenage daughter that was diagnosed with cancer. When I found that out that morning, that she was diagnosed with cancer, I had no business working around electricity at all. And I had as much experience as probably nearly anybody there was. It's what happens to us at home. There's this whole notion that you'll hear about, don't take your work home. That's baloney. We all take our work home. I don't care how hard you try, you're going to carry some aspect of your work to the house. Don't bring your home life to work. You're going to do that too. And what happens is, if you're having a bad day, there are some things you probably shouldn't do. If I'm going to walk a tightrope between this building and that building, I probably shouldn't do that if I'm having a bad day. It don't matter how good I am at it. It don't matter how much experience you have at it. Everyone is susceptible to human mistakes. And the reason we have the regulations, the mitigation, the hierarchy that says de-energize it is not because I don't have the experience or the qualifications to work on energized electricity, but it's maybe because I make a mistake. And that mistake is fatal. The young man that died with the utility company was very experienced in what he was doing. He knew what he was doing. He was having a bad day that day, though. And there were some things going on from home. And he made a mistake, and that mistake cost him his life. And it cost some little kids their dad, and a woman her husband, because they made a mistake. So this stuff isn't that we can hire the best guys and they won't make mistakes. There is no such thing as the best guys that won't make mistakes. We all make mistakes. So what we have to do is we have to put things in place to mitigate these mistakes. And it starts with you doing what you're doing right now, and that's learning at a very high level overview of what this is. Each and every person in here needs to have at least a 4-hour NFPA 70E class from somewhere. Don't call me if you don't want to, but get it somewhere. You need to learn about what electrical safety is all about. And what I recommend is for management people and oversight people to have at least 4 hours of it to learn what's in it. You all should own a copy of it if you've got electrical workers working for you. And if you're in the electrical working industry, our class for electrical workers, we're having one next week, is 12 hours long. And that's the one for electrical workers. If any of you want that class, you can see, Wes, that class is fine for you too. You'll learn a ton about how to manage your electrical hazards. But we have these classes every month. But so does a lot of other people, okay? I'm not trying to pitch you on using us. What I'm trying to get you to do is to use somebody. Learn about electricity, learn about the safety aspects of it. Because we live in a world sometimes that we all are running around minding our own business, not really paying attention. But I don't care who you are your brother's keeper. We are here on this earth to look out after one another, look out after the people we have, And I had a young man that was in one of my classes a year ago that died at Love Field when he fell off a building. And I remember his face, and I remember who he was. And he's one of many whose faces I remember. And I'm telling you, we don't want to carry that home with us. Even if it's a contractor that we have out there, the HVAC guy, and I'm not just picking on them, it's just they're in harm's way so much because of what they're working around. We are a brother's keeper. Look out after each other, care about each other. Okay? It's not only doing the right thing is good business. Anybody that tells you any different don't have a clue what they're talking about. Doing the right thing is good business. Taking care of your people is good business. Watching out for each other is good business. All these things are good business. So I'd encourage you, pursue more knowledge about what this is all about. We all work around it, and you need to know more about it. And like I say, if we can help guide you in it somehow, let me know. We'll do that for you. Do I have any questions at this point? I think we got a few minutes for any questions you may have. Nothing? Go ahead. Do what now?
You have classes pretty regular about a lot of different things.
Have them all the time. Yeah. Yeah, we're in Louisville. We do two things. I do the classes at our training facility in Louisville, and I can come to your location and do them for you wherever you're at.
I've actually talked to Wes about doing those for us as a group or individuals.
Yeah. Like I say, I got one coming up this week that I still have a few openings for. If somebody wants to try and get in it, you can. It's on Tuesday and Wednesday, half a day on Wednesday. Any other questions? Anything at all, guys?
Is that what y'all do mainly is work on the switchgear stuff?
That's what we do. We do everything dealing with electrical from generation to distribution to transmission, from 120 volts to 765 kV. We've got guys working with utility companies and buildings.
Sometimes you have these AC guys come out and they'll in those buckets, they'll snap off your little on-off switches and those old equipment. Can you ever replace that stuff? Can you get that fixed? Or
We can, yeah. We can help you get that replaced and fixed. You bet.
is that what it is?
Yeah, super glue does work. You got to use the UV light. So Gorilla Glue won't make it. Duct tape will fix anything, man. Super glue and duct tape, and you can build a city.
Screw in there, and is not the answer. Okay.
Anything else? Got any other questions, guys? Seriously, go ahead.
Is there a standard of when you should do a clean torque or do a thermal scan? Because you hear everybody talk about different.
That's because there's lots of views on it. Really, you have to evaluate every case, and that's something we can help you do. You can ask us, we can come give you an idea and evaluate for you. It's based on the serviceability of the equipment. How old is the equipment? How well has it been maintained? What environment is it in? Is it in a nice, clean, air conditioned? Like we had one sitting outside the door here, it'd be in a great environment. You don't need to do that as often. So what I would recommend to anybody, instead of trying to take somebody's fast, dirty method for how to do maintenance, evaluate your hazards, your situation, your equipment, and tailor the maintenance to your circumstances. And that's really the best way to do maintenance. It's not just adopt some single philosophy that's out there. It's customize it to what you have by having a subject matter expert that knows what they're looking at, give you that evaluation.
There's no set standard from
Nope.
NFPA or.
No, not really. They all have different views, and there's things on how to do it. The manufacturer tells you got to do certain things at certain intervals. Those you should always do at the intervals they say, but get somebody to evaluate the equipment for you. And any of the companies that do what we do, not just us, any of them can do that for you. Anything else? Well, guys, I appreciate your attention to this very much. As you can tell, it's very important to me and it's very close to my heart. Not having my guys get hurt or not having any of you get hurt. I'd be really sad if any one of you got hurt too. Okay? So y'all have a great day, and it was a pleasure being here. Thank you.
Thank you.